Good morning. Welcome once again to the continuation of our studies on the singular numerical relativity, which is the completion of general relativity. We already learned that numbers are real. Numbers are real like objects. Therefore, they undergo operations which we call physical operations, in addition to the four fundamental operations that we know in classic mathematics. And we began already with the second chapter. We learned about how this happened in one dimension, two dimensions. Today, we will begin with the three dimensions. So, we are talking about the three-dimensional vibration of a number. And these happen as projection and explosion. So these are the only two operations that allow us to go up to the three dimensions. Why we need this? It's because we need to truly get all the information about a number. We need to gather all the features that a number has, because later on we will be mapping the information on a card, because every number has an ID card or an information card. So what we are going to do is to build an object, a geometric object that we can use in order to know all about a number. The details that we need, that's what we want to find at this time. So to begin with, we will go for the projection of a number in three dimensions. You have a number 4. Number 4 occupies a location. This location is in form of a cube. Why? Because this time we're talking about the three dimensions. You saw last time that it was just a cell, because two dimensions. Now we are talking about three dimensions. Therefore, we call this a voxel. I think the idea about this word voxel is volume. No? So that's why maybe they put this one. I don't know exactly the story about the word itself, but I think that's the way it sounds. So, as a cube, it has 6 sides. You see here, side 1, this one very visible, 2, 3, 4, 5, and at the back there is 6. So if you have a cube, you have 6 sides. Then the projection takes place in 90 degrees. This must take place in 90 degrees. So we have to use the 90 degrees this way. Now we can build it going that way. Therefore, we will need to cover 3 sides only. So we get one corner here, and this corner is here is related to 3 sides. Then we will use those 3 sides in order to build our object. So you see what we do is this first. We put small cubes of the same size of this to form another cube. So far, the initial cube is 1 cube. Now we need to make 2 cubes. So 2 cubes, we need to cover the third side, which is this, the third side. We cover it totally to make 2 cubes. So now we can know how many small cubes we added for us to form the 2 cubes. So we went from 1 cube, now 2 cubes. So we had a certain number. Actually, we are going to see all those details in a while. So we have to notice that there is a certain number of cubes we are adding all the times in order to form the next cube. We did the same for the projection in 2 dimensions. We had to add 3 cells or 3 locations, 3 values at the first step or the first level. Now, to the second level, we will do the same. We will wrap first on the sides, then to make the 3 cube, we have that. So there is also a number of cubes we have added. So what we are adding to make a new cube is what we call the cubic arrow. In 2 dimensions, we called it the square arrow. Now it's about the cubic arrow. The cubic arrow is the value that you add to an existing cube in order to get the cube of the next level. It's very simple as that. We will see that through the numbers actually. Let's go now to the next, because number 4, in order for it to complete its projection, it must go 4 steps. So now, so far we have gone only 2 steps or 2 levels. So we have to go to the 3rd level and the 4th level. Let's do it. This is the 3rd level. To complete it, we have to cover there. Yes. Next, the 4th level, we have that and we cover. So what we have been adding is what we call the cubic arrow. Now, if we want to know the whole here, you have just to count how many small cubes that this huge cube contains. So we have to see, we can count. We go 1, 2, 3, 4, 5. 1, 2, this is Y, this is X, and we can take also Z here. We will have also 1, 2, 3, 4, 5. So 5 by 5 cube, this 5 by 5 by 5. Then we can calculate that, of course. This becomes the projection of number 4. The projection of number 4 is calculated as 4 plus 1, because we made 4 steps. So we plus the initial, so that's 5. It's you get the number of levels cube. That's it. So 5 cube, that's 125 locations. You know what it means here? It means that number 4 projected in 3 dimensions can occupy 125 locations. That is increasing. Recently, when we were talking about the 2 dimensions, we had only 25. That's what we said. But now with 3 dimensions, we have gone up to times 5 again. So it means we have 125. This is a huge. This is a very big. Imagine just 4 now. And as I explained already before, that it means here that number 4 can be in 125 places at the same time. That's a lot. Even particles cannot do, maybe. I don't know if the particles can do what numbers do, because numbers really do it. So we see here what we have gone through. We have been developing this, starting with 1 cube, 2 cube, 3 cube. So what we are adding all the times to make the next cube is what we call the cubic arrow. Then the whole volume here, to calculate it, you just get n plus 1 cube. That's it. As simple as that. Next, we can see now the cubic arrow in details. Let's see the different values of the cubic arrows. You see, just bring back. That's so we try to isolate each level at its own place, and you see that's very clear. It's a 3D image, so you can see it very clearly as it is presented. We start with 1 cube. Then to make the next cube, you check very well here. We have to have 1, 2, 3, then 4, 5, 6, 7. We add 7. So these are the numbers, as you see. To make 2 cube, we added 7 to 1 cube. Now, to make 3 cubes, we have to add 19. So if you check well, you count well, all of these are 19. We will do the breakdown again later in the next slide. So we will have another, you will see it very well, so I don't anticipate. Here, to go to the 3rd level, on the 3rd level, of course, we have to add this. So these numbers you see here, the 1, and let's say plus 7, plus 19, plus 37, plus 61. So these numbers represent what we call the cubic arrow of different levels. When you add them, then you get the next cube. So you can continue. This can continue if you want. We have a bigger number, so we can continue making the. This is level 4, level 5, level 6, but there is a formula that we are going to find how to reach to there. How this change happens, how these cubes are formed. You see, we learned in school, in high school, in algebra. This is one of the famous formula in algebra. A plus B cube. We call this remarkable product. I think you remember all about this. Remarkable product. This remarkable product gives us the result as A cube plus 3A squared multiplied by B, then plus 3A multiplied by b squared plus b cubed. This is the formula. What it means, that if you have initially an a cube, for you to get another cube by adding a certain level, which is here b, then you need to add this number here. This is the value. So this is only one value as you see it. That's what you see here. 19, 7, 37, and 61. So those values come from this formula here. And this is called the cubic arrow. We add, so in n, well, let's go now in numbers now. It means we have a certain cube, for example, of a number 2. Now we have to access to the next cube. We have to add 1, meaning the value now become n plus 1. Then to go to that, we consider the cube here plus the value that we have to add in order to form the next cube. This is a very important thing to, they are small things actually. You learn the mathematics, of course, in school like this. This little algebra that we have. But nobody explained to you what exactly it means. And here we are showing you exactly what it means and how we got all those answers we were making before. Then we go to this level. Now let's see, these are only the examples for you to see exactly where this 3n squared plus 3n plus 1 come from. How they are related exactly to the cubic arrow. I choose to present you from level 2 because level 1 here it's a bit confusing because of this 1, so you may get confused easily. But let's start with level 2 so that we can make the difference, and level 3. So I will show you only how it works. So we had to find 3n squared and plus 3n plus 1. So we go, first we remove the 1. You see that one in the corner, removed and put in 1. That's the 1. Now, the n, the 3n, it means the value, since we are on the second level, so the n here is 2. So we bring the 2, the first 2, the second, and the third. So we are emptying our, our content here. All are coming from here. So these are the 3 times 2. That's what I mean. 3 times 2, and the remaining, we separate a bit to see it clearly. So we separate. This is n squared, and n squared. So 3n squared, and this n is 2, so meaning 2 squared, which is 4. As you see, 4 here, 4 here, 4 here. So now sum up all the numbers for level, that's level 2 we are talking about. For level 2, you will have the numbers. Here you have 3 times n squared, which is 4, is meaning 12 here. Then here 2 is that's 6 plus 6 equal 18 plus 1, 19. And if you check in the previous slides, we saw plus 19. So the level 2 is 19. Level 3, we go remove first the 1. It goes there. Then now let's bring the 3n, which are 3, 3. 3, 3. You see that? 3n. Then the remaining, let's see it well, it should be 3 squared. 3 squared, 3 squared, 3 squared, 3 squared. You see that? And the number, if you calculate this one, you will have, the number here is known as, the total of this is 37. 37. That's level 3. 37. That's the square arrow, or the cubic arrow, sorry. The cubic arrow of number of level 3. Level 3. Okay. So we have learned, and I am explaining to you that we are getting all these data. This is only a demonstration, you see here. This is a demonstration because you learned this mathematics before, but you never understood how. Just memorize. I myself, I was so good in this. In this algebra. Algebra was my favorite subject, actually, in math. Very good at that. I was very top in this. Maybe in other mathematics I didn't do well, but at least in algebra I was so good. I was so good. So let's go to the next. We now talk about the three-dimensional envelope. We will go to talk about the three-dimensional envelope, or the three-dimensional explosion of a number. Now it is explosion. We have the number here. Explosion means in all directions. All directions. West, south, east, north, all. I already showed you it is like our sun is a ball of light. So in any side you will be of the sun, you will receive the same degree of light. So the sun has no boundaries. That's 360 degrees. So here we have to cover this cube 360 degrees. So we start wrapping around. Let's go. We do this. Then that's complete. You still see that there is a red here showing, and if you look at it also down here, the red must still be showing because it's only one. So we have to add to cover it to have a perfect cube. So the cube, we went from the cube of 1 to the cube of 3, and here what works is 2n plus 1. Because this is an expansion. Expansion in all directions. So me 2n plus 1. Explosion or expansion in all directions is the same thing. That's how you have to understand the operations. So we have 3. Now we go to the next level. We wrap again. Here and down, because the yellow is still showing. Up. Now we have full. You see the cube here is 1, 2, 3, 4, 5. So this is cube of 5. We go to the next level. This we will be getting cube of 7. Here and there. You count 1, 2, 3, 4, 5, 6, 7. So the numbers in explosion, you have 2n plus 1. That's why we have only odd numbers. So odd, the cube of odd numbers. We are forming a cube around a cube by enveloping this. So this is what we call the cubic envelope. We had the squared envelope in just 2 dimensions. Now the cubic envelope in 3 dimensions. So it's very clear that you see it has how it works. Now the last level comes. This is the last level, which is level 4. Oh my God, look what is happening. And we add, and we add. Oh, huge. Now to calculate all of this, of course, as I told you, 2n plus 1 cube. That's all we have to do to calculate this. N is 4. So 2n, 4 plus 1 cube. That's 9 cube. How many? 729. Oh, this is big. Number 4 can explode and be in how many locations? 729. That's big. That's why I told you, let's use only small numbers. Because if we go for numbers like 10 already, that's what it will be exaggerated. We will not be able to cover that. So it's huge already. You are using only 4 as 4. 4. But here it says there are 729 ways to use. 700. That's the maximum. That's the maximum. So it is big. And to calculate that, of course, as I told you, you have to get 2n plus 1 cube. That's simple. As simple as that. Next, we have to go to see now exactly the inside. Because we have to know the details inside this cube. Now we have opened up this cube, removed some of the bricks and some of the voxels. We removed them so that we can see the inside. This is number 4 that exploded. It went boom, yellow, boom, green, boom, orange, and boom, blue. So 4 times it went exploding. Just like fireworks. Boom, boom, boom. That's how you have to understand it. So now you see that we have this number. We can count by level, per level, how many. When we were putting them during the construction, we just put, but we did not count. Now we count them. So at the first level, we have 26. How we get the 26? We have to get 24 times 1 square plus 2. 1 square is 1. So 24 plus 2. That's how many? 26. So you see, this is already at the first step we have 26. That's what we are showing here. Level 1, 26. Level 2, you apply the same formula, just replace here by 2. When you put 2 here, you have 96 here, then plus 2, that's 98. Level 3, you have the number here. When you apply 3 there, we have 9, the 24 multiplied by 9 plus 2. That gives you this number. We have 218. Then level 4 now, we go to this level, just put 4 here. Then you have 16. No, 24 times 16 plus 2. That's what gives you 386. So you have now all details about the cube. And when you sum them up, you have this number, 729. This is wonderful. So you see how we are really trying to understand numbers, how they work. So numbers explode and they can give us all these degrees of freedom, so many possibilities. And you see the numbers are huge numbers when it comes to the explosion. So I want to mention something to you, because in chemistry we talk about, you know, the table of elements in chemistry. Mendeleev table, I don't know you call it. So there it says that the most stable element is the ion. You know why? Is number 26. The ion has 26 protons. That's why it is the most stable. So that 26 is dictated by the heavens or by nature itself. It's a natural law. That's why 26 is very stable, because when you have a cube like this, there is no other structure that can give you a perfect stability as you see in this cube. So that's why the ion is the most stable element among all the elements that we study in chemistry. So this is a revelation that I'm giving to you. Now, let's go to the last point, where we will check a little bit all this detail, but we will just limit it to up to the level 3 only, as we have done in the projection. We go up to the level 3. So I will show you this. This is the cube of level 3, the whole. So inside there are all the small cubes we saw, level 1 and the initial level, which is for the inside here. Now we want to know exactly, find out those numbers we have found here when we saw numbers 26 and 98, 218. You see, yeah, those numbers we want to find out. So here, to calculate, of course, this cube, we have the formula. You have to go, just use the level number, n level number, multiplied, level number plus 1, and sorry, level number multiplied by 2 plus 1 squared. That's the way we have been doing, 2n plus 1 cube, sorry. Here is cube. So let's see it here. We open a little bit this. Let's open. You see, it's open. Then now we begin to see the yellow. Remove the other cover, or maybe on the one on top, we remove. And the one on the sides, we try to separate a bit. Okay? So we can see now all the content of level 2 in green, level 3. So if you want to know now this, you will have to calculate this way. 24n squared plus 2. 24, 2 squared plus 2. So that's what we have. Anyway, you see the numbers. Up to 98. This is the second level. For the first level, just replace 1 here. You see the blue, so you put 1 here and 1 here. You replace the 1 squared, and here also you have to place 1 here, and you have the number, so the number will come here is 24. Then you have 26 as a total. 26, as we have explained already. So this is how we can scan the content of the object itself. So this is why we limit ourselves for this explanation of the 3-dimension explosion and projection, what we call the 3-dimension vibration of a number. The purpose is to know the content of an object built by using the procedures that we have here. So each one gives us some results, and those results are very important for us to establish an ID card for the number. And I tell you, there will be 2 kinds of ID. You see that the explosion is so big, so this is a big card. The other card is only for the projection, which will be smaller. And they are very important for some reasons that you will understand as soon as we begin to study them. So for today, this will be our end for this 3rd chapter that we have learned about. All I will still tell you, please look, listen, and learn. This is not for me, it's for your own benefit. Because if you don't study this one, tomorrow you will be miserable. In the sense that you will regret. You had an opportunity in your lifetime to know these things, but you didn't do it. So please follow me in the next chapter when we will be discussing about the holographic principle. We will see now how the holographic principle works. This is amazing. Many miracles will happen. So see you there. Thank you very much.